morning to all. In previous class already we discussed about noise. So in today's class we will go to next half part of the last unit, that is pulse modulation. So pulse modulation, put a heading pulse modulation. So the next half part of last unit is pulse modulation. To know in AM, FM and PM, the carrier is in form of analog signal. But in case of pulse modulation, the carrier is in the form of pulses. So that's why it is called pulse modulation. Pulse modulation. Before going to pulse modulation, you must know about the sampling. So what is meant by sampling? The process of converting an analog signal into a discrete signal is known as sampling. What is sampling? The process of converting an analog signal into a discrete signal is known as sampling. How the sampling is done and how we will take the time period for each sample. Suppose if we consider the signal, analog signal is like this. One second. So this is a continuous signal or analog signal which is mentioned with f of t, which is mentioned with f of t. And if we want to convert this analog signal into a discrete signal, so like this. So discrete is nothing but here we have some pulse according to this analog signal amplitude. According to this analog signal amplitude, this analog signal is converted into a discrete signal. That is, it will have some amplitude. It has some amplitude. So this signal is called a sampled signal. So that is, after conversion of analog to digital, the signal is called sampled signal. How this analog signal is converted into discrete signal? Here if we take a continuous signal as the input for switch S, So if the switch is closed, then the signal is appeared, the continuous signal is appeared for a particular time. So at the output we got that particular discrete signal. So that is, here we apply a sampling signal train which have the time period, as Ts, that is known as a sampling time. And during this time the switch is closed. Whenever the switch is closed, that sampled signal, that is this sampled sampling signal is appeared at the output. So after a particular time when switch is closed, that the sample signal is not appeared at the output. So with the help of single switch we can convert analog signal into digital signal. So for that purpose, if we apply a continuous signal and sampling signal is nothing but it is a pulse train. It is a pulse train which have the unit amplitude and time period of capital Ts. The time Ts is known as sampling time, and during this time switch is closed, so that the sample signal is equal to the input signal. సో ఎప్పుడైతే మనకు స్విచ్ క్లోజ్ అవుతుందో కంటిన్యూస్ సిగ్నల్ యాంప్లిట్యూడ్ని బట్టి మనకు అవుట్పుట్లో వచ్చేసి శాంపుల్ సిగ్నల్ డెలివర్డ్ అవుతుంది. సో వాట్ ఈస్ ద కంటిన్యూస్ సిగ్నల్ యాంప్లిట్యూడ్? సో ఇఫ్ సపోజ్ ఇఫ్ యూ కన్సిడర్ at this point it have the maximum amplitude. So according to this maximum amplitude, the signal, the pulse at that time is delivered into the output. So that's why here the pulse amplitude is having maximum amplitude, having maximum amplitude, so that the modulating signal is converted into is converted into discrete signal. Here what is the modulating signal? Analog signal. So that is the continuous signal is converted into discrete signal. This process is called sampling. This process is called sampling. So by the help of only single switch we can get this sample signal. We can get this sampling signal. This is just for introduction. So totally here the important point is the carrier is like a pulse train. That is we will send a pulses. We will send a pulses. But in case of previous techniques, the carrier is in the form of analog. So that's why this technique is called pulse modulation. This technique is called pulse modulation. So coming to the types of pulse modulation. Coming to the types of pulse modulation. So these are the types of pulse modulation. Under pulse modulation, again we have two types. That is analog pulse modulation and digital pulse modulation. Analog pulse modulation and digital pulse modulation. Under analog pulse modulation, again two types. One is a PAM, that is pulse amplitude modulation, and another technique is pulse time modulation, which is nothing but PTM. Under analog pulse modulation, again we have two techniques. One is PAM and another one is PTM. Another one is PTM. So here the data is transmitted in terms of pulses. In terms of pulses. Again, under PTM, that is pulse time modulation, again we have two techniques. One is pulse width modulation, PWM, and another one is pulse position modulation, which is nothing but PPM. PPM, pulse position modulation. So under PTM, again we have two techniques. One is PWM and another one is PPM. PPM. Under digital pulse modulation, again we have two techniques. One is pulse code modulation, PCM, pulse code modulation, PCM, and second one is delta modulation. What is the difference between analog pulse modulation and digital pulse modulation? In analog pulse modulation, the data is transmitted in the form of pulses. In the form of pulses, and the pulse characteristics, that is either amplitude, width, or position, is changes according to the amplitude of the modulating signal. Is changes according to the amplitude of the modulating signal. But whereas in case of digital pulse modulation, the data is sent in the form of bits. So that is the digits either 1 or 0. In case of digital pulse modulation, the data is sent in the form of digits like binary digits, that is like either 1 or 0. So in case of analog modulation, the data is sent in the form of pulses and whose characteristics characteristics is changes according to the amplitude of modulating signal. According to the amplitude of modulating signal. In case of previous techniques, that is AM, FM, or PM, the carrier is in the form of also analog signal. Analog signal. The characteristics of carrier is changes according to the modulating signal. So those are, if it is a AM, according to the amplitude, the carrier signal amplitude is changes. If it is FM, according to the frequency of modulating signal, the carrier frequency is changes. But here the process of changing any one of the characteristics of a train of pulse in according to the amplitude of modulating signal is called pulse modulation. If we changes the amplitude, then it is called PAM. If we changes the amplitude of pulse according to the amplitude of modulating signal, then it is called PAM. So totally in our syllabus we have PAM, PWM and PPM. These three techniques. PAM, PWM and PPM. What is PAM? If the amplitude of the pulse is changes, amplitude of the pulse is changes in accordance with the amplitude of modulating signal or message signal is called PAM. So here, that is what is the observation here? The characteristics of the pulse is changes. That is either in the form of amplitude or width or position according to the amplitude of modulating signal. So if there is a change in amplitude, then it is called PAM. If there is a change in width of the pulse according to the modulating signal amplitude, then it is called PWM. If we change the position of the pulse, if we change the position of the pulse according to the amplitude of modulating signal, then it is called PPM. Then it is called PPM. So totally in your syllabus, you have these three topics: PAM, PWM, and PPM. Now, first technique we decided in PAM, generation of PAM. So, not only the definition for PAM, what is PAM? The process of changing amplitude of the amplitude of the train of pulse, train of pulse, in according to the amplitude of modulating signal, in according to the amplitude of modulating signal is called PAM. It's called PAM. So that is, in case of PAM, the process of changing amplitude of the train of pulse. In accordance with the దేని బట్టి చేంజ్ చేస్తున్నాము amplitude of modulating signal or message signal. The process is called PAM. సో టోటల్గా ఈ మూడు టెక్నిక్స్లో మీరు మెయిన్గా యూస్ చేసే టెక్నిక్ వచ్చేసి శాంప్లింగ్. శాంప్లింగ్ అంటే ఏం చెప్తున్నాం మనము అనలాగ్ సిగ్నల్ వచ్చేసి కంటిన్యూస్ సిగ్నల్ ఆర్ అనలాగ్ signal is converted into the form of discrete signal. Converted into the form of discrete signal is called sampling. Now if you observe the waveforms, this is the form signal, that is PAM signal. PAM signal. This is PAM signal. So this is the message signal, that is nothing but modulating signal. If we represent that signal as f of t or x of t, here we apply a pulse train. Here we apply a pulse train having an amplitude of unity by passing through PAM modulator. By passing through PAM modulator, we got this PAM signal. We got this PAM signal. So if you observe this one, the output signal is in the form of discrete, and the amplitude of each pulse is varies in accordance with the amplitude of message signal. If you observe this waveform, the amplitude of each pulse is varies in accordance with the amplitude of message signal or modulating signal. Suppose if you observe at this point, if you observe at this point, suppose here we have 2 volts, 2 volts amplitude, 0.2 volts amplitude. So according to that 0.2 volts amplitude, here the discrete signal is generated. So entirely at the envelope of these pulses, we have our message signal. If you observe, this is PAM signal. At the envelope of this PAM signal, we got our message signal. We have our message signal. If you observe each pulse shape, it is have some slope. If you observe that each pulse shape, it must have some slope. That sloped pulses are called natural PAM signal. Natural PAM signal. To generate a flat top, for each pulse. Again, the signal is passed through pulse shaping networks. Again, the signal is passed through pulse shaping networks. So that is by passing through pulse shaping network. Here we have a flat top for each sample. For each sample. Observe the difference between the signal and the signal. So after passing PAM modulator, we have this signal. So to got a flat top, we must pass through also shaping networks. Now coming to the block diagram of PAM generator. So this is the block diagram for PAM generator. Generator is nothing but modulator. PAM modulator. So what are the internal blocks for PAM modulator? The first we have a low pass filter. So after that multiplier. So after that multiplier, again we have two inputs. One is from low pass filter and another is from low pulse train generator. That is what is the signal here? The signal at this place is, it is a pulse train. So like this. Which have a constant amplitude. That is, we apply some pulse train at this point. Again, here what is the low pass filter purpose? Here what is the input for low pass filter? సో మీరు ఏదైతే ఏ మెసేజ్ సిగ్నల్ అయితే మనం మాడ్యులేట్ చేయాలనుకుంటున్నామో పిఏఎం చేయాలనుకుంటున్నామో ఆ సిగ్నల్ ఇక్కడ ఇన్పుట్లో అప్లై చేస్తాం. సో దట్ ఈస్ హియర్ ద సిగ్నల్ ఈస్ మాడ్యులేటింగ్ సిగ్నల్. దట్ ఈస్ that one. So by here we take the first stage as low pass filter. Always the modulating signal have low frequency. So to eliminate any unwanted high frequencies, we must first pass through low pass filter. So if any high frequencies are present in our message signal, those two components are rejected by low pass filter. So at the output of low pass filter, here we have a perfect modulating signal. So for this multiplier, here we have two inputs. One is modulating signal, that is message signal R, and another one is pulse train. Which have each pulse has a particular time period, that is TS, sampling time. TS. Each pulse have a time period of TS. So at the multiplier stage, this signal is multiplied with this signal, then automatically it generates a pulse train whose amplitude is varies in accordance with the amplitude of message signal. సో ఎప్పుడు మనకి మాడ్యులేటింగ్ సిగ్నల్ ఒక ఇన్పుట్ అప్లై చేసాము, సెకండ్ ఇన్పుట్ దగ్గర మనం పల్స్ ట్రైన్ అప్లై చేసాము. సో వాట్ ఈస్ ద అవుట్పుట్ ఆఫ్ మల్టిప్లైర్? సో టోటల్లీ ఎట్ దిస్ స్టేజ్, దట్ ఈస్ ఇఫ్ దిస్ sample is multiplied with this modulating signal, then automatically at the first stage, here we got first sample. So if you observe for each pulse, since it is a pulse train, for each pulse it has some gap. So at that gap there is no signal. Since here we apply these two signals with the multiplier circuit, so that's why at the gap of pulse train there is no signal present at the output. Again for second pulse, and that pulse is multiplied with this modulated signal, and again second discrete signal is generated. Similarly, at the output of multiplier we got this pulse train whose amplitude is changes in accordance with the amplitude of message signal. Now, so that is at the output of this one multiplier we got this signal. ఈ షేప్ సిగ్నల్ మనకు అవుట్పుట్లో మల్టిప్లైయర్ దగ్గర జనరేట్ అవుతుంది. Now, so to shape each pulse, here we use a pulse shaping network. So the output at the pulse shaping network is flat top shaping. So that is each pulse have flat top. Like this. So for that purpose, internally we have a pulse shaping networks. So this is the procedure to got PA. So totally PAM generator consists of a low pass filter, pulse train generator, multiplier, and pulse shaping network. So with the help of low pass filter, we reject if any high frequency components are present in the message signal, those are rejected by low pass filter. So at the output we got our original message signal. So and another input for multiplier is we continuously apply some pulse train, with have the time period of Ts, that is sampling time. So when this pulse train, that is for each pulse, when each pulse is multiplied with the modulating signal, automatically at the output we have a pulse train whose amplitude is changes in accordance with the amplitude of message signal. So at the multiplier output we got this signal. So, but each pulse have some slope at the top. So to remove that slope, we got flat shape. We have passed that signal through pulse shaping network. So at the output of pulse shaping network, we got a PAM signal. Already I told you what is PAM signal. The amplitude of each pulse is changes in accordance with the amplitude of message signal. So note down the waveforms and block diagrams. Note down the waveforms and block diagrams. these are the waveforms for PAM. Waveforms for PAM. So this is the generation of PAM signal. Now coming to the detection of PAM, just with the help of diode detector. With the help of diode detector, we got our original message signal. సో ఆల్రెడీ చెప్తున్నాం కదమ్మా, మనకి ఎప్పుడు కూడా మనకి యాంప్లిట్యూడ్ మాడ్యులేషన్ ఎలానో పిఏఎం అలా. సో యాంప్లిట్యూడ్ మాడ్యులేషన్లో మనకి మెసేజ్ సిగ్నల్ అగైన్ డిటెక్షన్ మెథడ్ ఏం చెప్పాను నేను, ఎన్వలప్ డిటెక్టర్. సో ఆల్వేస్ అవర్ మెసేజ్ ఈజ్ ఇన్ ద ఎన్వలప్. Always our message signal or modulating signal is in the envelope of the modulated signal. Therefore, to extract our original message signal, we must pass through envelope detectors. Similarly, here also we have a diode detector. To extract our original message, we use a diode. Depending upon the diode forward bias and reverse bias conditions, we can extract our envelope of modulated signal. Then automatically we got our message signal. So therefore the input is diode detector is a palm signal, that is PAM signal. మీరు ఏదైతే సిగ్నల్ ని డిమాడ్యులేట్ చేయాలనుకుంటున్నామో that PAM signal is applied at the input for diode detector. Inside we have a diode as a main component. Depending upon the diode forward bias and reverse bias conditions, at the output here we got a envelope. Envelope is nothing but here, this one. In the envelope only we have our original message signal. So to eliminate this internal pulses, to extract only envelope, we use diode detector. So that is at this place. What is our signal? At this place again we have a all internal pulses are rejected. Only envelope is detected by the diode detector or envelope detector. Only envelope. Since it is a low frequency signal, once again if we pass through the low pass filter, if any high frequency components are presented, those are rejected by low pass filter. At the output we got only our original message signal. That is called a demodulated PAM signal. If our message signal have the frequency of FM, maximum frequency of FM, the low pass filter removes all the frequencies above FM and it allows only FM frequency. Therefore, at the output we got our original message signal. And here what is the PAM signal input? This is in the form of like this. So already తెలిసి ఇదే ఈ షేప్ లో మనకి ఇన్పుట్ లోకి వస్తుంది PAM signal. సో ఇవన్నీ కూడా సింపుల్ టెక్నిక్స్ అన్నమాట. జనరేషన్ మెథడ్స్, డిమాడ్యులేషన్ మెథడ్స్ అన్నీ కూడా మీకు ఈజీగానే ఉంటాయి. జస్ట్ మీకు ఇక్కడ గుర్తుంచుకోవాల్సిన PAM అంటే ఏంటి, PWM అంటే ఏంటి, PPM అంటే ఏంటి. PAM, PWM, PPM వీటన్నిటిలో కూడా మనకి modulated signal is in the form of pulses. The amplitude is changes, then it is called PAM. మనకు ప్రీవియస్ టెక్నిక్స్ అన్నీ కూడా ఎలా చెప్పుకున్నాము, యాంప్లిట్యూడ్ చేంజ్ అయితే దాన్ని AM కింద చెప్పాను. సో అలానే అగైన్ యాంగిల్ కనుక చేంజ్ అయితే దాన్ని యాంగిల్ మాడ్యులేషన్ అన్నాము. Again the angle is changes in two ways. One is frequency and another one is phase. If we change a frequency, then it is called frequency modulation. If we change a phase, then it is called phase modulation. Similarly, here also we have a amplitude modulation, that is amplitude variations, and another one is a time variations. Again in time is varied in two ways. One is width and another one is position. If we changes width, then it is called PWM. If we changes position, then it is called ppm. So this is a detection of PAM signal. Now coming to the bandwidth requirement for PAM. Transmission bandwidth for PAM signal. So observe carefully. Here we take each pulse duration as tau. Each pulse duration. Suppose in the PAM signal, PAM is nothing but pulse train whose amplitude is changes. So therefore, here each pulse amplitude is changes in accordance with the amplitude of message signal. And this pulse width is considered as tau. Tau. Take this pulse width as tau. And each pulse is separated with a time period of Ts, with a time period of capital Ts, that is this one, this one. So pulse duration is tau, and separation between pulses is considered as capital Ts, capital Ts. What is our message signal? Message signal is always we considered as x of t, and the maximum frequency in the signal is considered as Fm. If we consider the maximum signal, maximum frequency, suppose this is our message signal. Now what is the maximum frequency? This one. Maximum frequency, this is a maximum amplitude, and maximum frequency, suppose for this signal we have a 50 kHz as a maximum frequency, then Fm, maximum frequency, Fm is considered as 50 kHz. Fm is considered as 50 kHz. The maximum frequency in the signal x of t is Fm. Suppose here we take a W. So total ఇక్కడ నేను 3 parameters చెప్పాను. One's వచ్చేసి pulse duration which is tau, and time period between two pulses. Time period between two pulses is considered as capital Ts, and the maximum frequency of our modulating signal, that is x of t కి maximum frequency W కింద తీసుకుంటున్నాను. అదర్వైజ్ ఇట్ ఈస్ ఆల్సో కాల్డ్ ఎఫ్ఎం కిందైనా మీరు రిప్రజెంట్ చేయొచ్చు. So according to sampling theorem, I think already you know sampling theorem in SS. According to sampling theorem, Fs should be must be always greater than or equal to 2Fm. So it is called Nyquist rate. It is called Nyquist rate. That is Fs must be, sampling rate must be, sampling frequency must be greater than or equal to 2 into maximum frequency of message. ఈ కండిషన్ మనకు సాటిస్ఫై అయితేనే పర్ఫెక్ట్గా మనము శాంప్లింగ్ థియరం తోటి మనం అగైన్ డిస్క్రీట్ కింద కన్వర్ట్ చేసి అగైన్ మళ్ళీ మన ఒరిజినల్ సిగ్నల్ని రీకన్స్ట్రక్ట్ చేయగలం. అలా కాకుండా ఈ ఫ్రీక్వెన్సీ, ఈ సిగ్నలింగ్ రేట్ మనం మెయింటైన్ చేయలేకపోతే మనం పర్ఫెక్ట్ మెసేజ్ సిగ్నల్ని రీకన్స్ట్రక్ట్ చేయలేము. సో దేర్ ఫోర్ వీ మస్ట్ ఫాలో దిస్ Nyquist rate. So what is our Nyquist rate? The sampling frequency must be greater than or equal to 2 into message signal frequency. That is 2 into Fm. Here I consider it as a W. So therefore Fs must be greater than or equal to 2 into W. 2 into W. So note down this expression. According to Nyquist rate, Fs must be greater than or equal to 2 into W. 2 into W. What is W? W is the maximum frequency of our message signal. Now, according to this equation, we can write 1 by Fs. 1 by Fs, since it is a reverse. So therefore, 1 by Fs is less than or equal to 1 by 2W. 1 by 2 Fs is less than or equal to 1 by 2W. But what is 1 by Fs? It is nothing but capital Ts. That is time period between each samples. So రెండు samples మధ్యలో ఉన్న time period ఇందాక ఎలా తీసుకున్నాం మనము capital Ts. So that is sampling rate. Sampling rate. So 1 by Fs is nothing but Ts. So therefore Ts is less than or equal to 1 by 2W. 1 by 2W. In brackets you note down, since Fs equal to 1 by Ts. Fs equal to 1 by Ts. But already we know that this tau is always less compared to capital Ts. This tau, what is tau? Pulse width. Pulse width is always less than the time between two pulses. So therefore, according to that, you write this expression: tau is always less compared to capital Ts. Capital Ts. So from this equation and this equation, we can write it as tau is less than Ts and Ts is less than 1 by 2W. So therefore, we frame one equation from these two expressions. We frame one equation from these two expressions. What is that expression? Tau is less than Ts and less than 1 by 2W. 1 by 2W. Suppose if we consider a PAM signal, on and off time of each pulse is same. On and off time of each pulse is same. So therefore, we can take the frequency of PAM pulse becomes 1 by tau plus tau. On and off time. On and off time. So therefore, F is considered as, what is F? F is frequency of palm. Frequency of palm pulse. F equal to 1 by tau plus tau, that is on time and off time, which is equal to 1 by 2 tau. 1 by 2 tau. So the maximum frequency of palm signal is considered as 1 by 2 tau. The maximum frequency of palm signal is considered as 1 by 2 tau. That is F maximum equal to 1 by 2 tau. 1 by 2 tau. And take the bandwidth required for transmission of palm signal will be equal to maximum frequency F maximum. Bandwidth required for transmission of palm signal must be greater than or equal to F maximum. But what is F maximum here? F maximum equal to 1 by 2 tau. So what is BT? BT is the bandwidth required for palm signal. అంతే కదమ్మా, మనం ఎఫ్ మ్యాక్సిమం సిగ్నల్ మనం డెలివర్ చేయాలి అని అనుకుంటే దాని బ్యాండ్విడ్త్ మస్ట్ ఎప్పుడు కూడా ఎలా ఉండాలి? ఎఫ్ మ్యాక్సిమం కన్నా ఎక్కువగా ఉండాలి. సో దేర్ ఫోర్ వీ కెన్ టేక్ దిస్ కండిషన్ BT, that is bandwidth required for palm signal, must be greater than or equal to F maximum. But what is F maximum here? 1 by 2 tau. 1 by 2 tau. But already you know tau is less than or less than 1 by 2 tau. Already you know tau is less than 1 by 2 tau. So పైనే వచ్చింది మనకి condition tau is less than 1 by 2 tau. So according to this we can write this as Bt is greater than or equal to 1 by 2 tau less than W. Less than W. So the transmission bandwidth required for PAM signal is must be ఎలా ఉండాలి? It must be greater than W. What is W? The maximum frequency of message signal. Maximum frequency of message signal. మెసేజ్ సిగ్నల్ మ్యాక్సిమం ఫ్రీక్వెన్సీ కన్నా ఎప్పుడు కూడా హైగా ఉండేటట్టు మనం బ్యాండ్విడ్త్ మెయింటైన్ చేసుకోవాలి. సో ద ట్రాన్స్మిషన్ బ్యాండ్విడ్త్ ఆఫ్ పిఏఎం సిగ్నల్ ఈస్ బీటీ ఈస్ గ్రేటర్ దాన్ డబ్ల్యూ. వాట్ ఈస్ డబ్ల్యూ? మ్యాక్సిమం ఫ్రీక్వెన్సీ ఆఫ్ మెసేజ్ సిగ్నల్. So in today's class we observe generation and demodulation of PAM signal and bandwidth for PAM signal. So in tomorrow's class we go to classification of PAM based on polarities. Classification of PAM signal based on polarities.